Hi all. In today's video, we're going to be looking at glacial erosional landforms. Now, there's a fair amount to get covered in today's video, so we'll skip the preamble and just get stuck in. Now, when we're talking about glacial erosional landforms, there's a number of different features that we need to consider. Now, the good news is the two main features, corries and U-shaped valleys, happen to comprise another 5 features just in their own formations, with the addition of a line or so on at the end of the formation. Those are for corries, arêtes and pyramidal peaks, and for U-shaped valleys, hanging valleys, fjords and ribbon lochs. Now we've got some other features as well. We've got roches moutonnées, crag and tail features, knock and loch and landscapes, striations and meltwater channels. Now we'll start today with one of the main features that we tend to look at, and that's corries. Now there's a lot of information on this slide, bear in mind I will also give you copies of these visuals because I know that I'll be blocking out a little bit of the text. But when we talk about corrie formation, there's a number of kind of key factors that we need to remember to discuss. And before I go any further, it's worth noting at this stage actually that in this video I have, bullet pointed these feature formations. You're obviously expected to expand these points out a lot more fully than what I have them on the screen. So first with corries, we're talking about the formation being favoured in north-facing hollows. Now, this is obviously comes with a caveat that it is not always north-facing hollows, but it's a preference for where they form. And the reason we have that preference is that if an area is north-facing, it gets less direct sunlight, so any snow or ice that forms there has got less opportunity to melt. So we've got snow falling in a north-facing hollow, and it's going to gradually compact over time. As it compacts, the air that's between the different snow crystals is going to vanish, and we're going to get something that's going to be called nave or firn. Now these are the same thing, and it basically just means compacted snow. So I always explain this as think about a snowball that somebody's kind of really went to town on. After more time and more compaction has taken place, we're going to lose even more air spaces between the snow particles, and we're going to be left with glacial ice. Now this is going to continue to happen, and we're going to have repeated times where we're going to have snow falling, turning into nave, turning into ice again and again and again and again over a number of years, and that's going to cause our glacier to actually grow and to form in the corrie. Now as it grows and the glacier forms, it's going to start to erode all of the rock that it's in contact with. Now we're going to start to see, and there's a typo on the slide, but I'm going to leave it at this stage. I'll make sure I edit it out for when I print these for you guys. That we've got plucking, we've got corrasion, and freeze thaw. While it's not being carried out by the glacier itself, it's a factor because the material that is frost shattered or broken up by freeze thaw can result in the glacier being a more powerful agent of erosion. So we've got all this happening. The glacier is plucking the material away. It's using that plucked material to wear away at the sides and the back wall of the corrie. And eventually the amount of ice we've got there is going to get so much and it's going to be so heavy that the glacier is going to start to move downhill because of gravity. Now it's worth remembering at this stage that the movement of this isn't going to be straight down because that would be passing through a mountain, nor is it going to just slide straight down slope because the ice is going to stick onto the rock at different points. So we're going to get a more rotational style of movement. Now, because we've got that rotational style of movement, we are going to see different amounts of erosion happening in different places. And this is really important when it comes to your diagrams, and it comes in at the end when we talk about the corrie lip forming as well. So as our glacier starts to move rotationally, the plucked rock makes it an even more effective agent of erosion. We've mentioned this already. And we're also going to see corrasion being enhanced by the formation of bergschrund crevasses. Now remember what I was saying about our corrie glacier, and that it's not just one coherent block of ice, it's lots and lots of little layers. And you're going to have some of those layers are going to be frozen onto the back wall of the corrie, and the stuff just next to it just isn't quite as tough. So as the glacier tries to move, it's going to go and it's going to break open. Now that presents a big deep chasm that bits of rock can fall into and make the glacier more powerful at eroding, or water can flow into and lubricate the glacier, meaning that it can move more quickly and again be a more powerful agent of erosion. Now remember when we were talking about that rotational nature of the movement, as we get to the front of the corrie it's moving up, so we can get a little lump of rock here that gets preserved, and we call this our lip. And it stays there because erosion at this particular point is just not as powerful as it is everywhere else in the quarry. Now behind that, when we get the glacier actually melting, if we've got a lip, if the geology in the area allows this to happen, we can also get a little quarry locking or a tarn forming. Now, this diagram has turned out terribly. As you guys can see, it just didn't cope well with being blown up, but you do have smaller copies of this in your notes that you can refer to. Now, moving on, when we talk about arêtes or pyramidal peaks, you explain a quarry. You must explain a quarry in order to explain either of these. Then for an arête, you're going to add in a line saying that an arête is two quarries that are back to back and it forms this knife-edged ridge that we see here. And pyramidal peaks is when you've got multiple, as in more than two quarries, forming back to back to back to back, and you get this very pronounced pyramidal triangular peak left in the middle. Now, our next major feature, our U-shaped valley. Now, it's good to think of U-shaped valleys flowing directly off quarries because they do. So I've got my glacier being formed up in a quarry. It flows out of the quarry and down into a V-shaped valley that an old mountain river or an old mountain stream used to flow through. Now, an important point to remember here is that glaciers don't work like rivers. Rivers flow around the landscape because they don't have the power to flow through them. Glaciers have that power. They can flow through the landscape. As it's moving through the landscape, it freezes onto different rocks and it plucks them away, and this increases the glacier's erosive power. The ice steepens and widens the valley, as in it erodes both laterally and vertically. Now again, when we think about a river valley, I always say, put your fingers together like that, and you can imagine that if that's a series of hills, that a river would flow around your fingers, creating these interlocking spurs because they interlock. If I have a glacier that flows down them, boom, it just cuts the end of the spurs off and they become truncated. How you see that is it's basically a flashy way for talking about the side of a U-shaped valley. This has all happened. All of this erosion has happened. I've got a much steeper, wider valley now, and eventually my glacier is going to retreat. It's going to flow back, it's going to melt back to its starting point. Once that's happened, the original stream might return, and we refer to that as a misfit stream. If in my valley during the periods of erosion I've got an area where there's some softer rock, that soft rock can get scooped out, and then when my glacier retreats and it melts, the deepened area that was created might fill with water, creating a ribbon loch. My other two, we've got these diagrams here again. You've got copies of these, and it's important to remember our diagrams with these feature formations, because a lot of the time in the exam, the question will be formed in the style of you must use diagrams in your answer. So it's important to include something like these. Now, our other features associated with U-shaped valleys, I've already mentioned ribbon lochs in the actual answer. If we were asked to talk about a fjord, we're talking about a U-shaped valley that connects directly to the sea. And then the U-shaped valley has flooded with seawater. These are particularly famous going up the coasts of Norway. If we're talking about a hanging valley, remember, glaciers flow down river valleys. Rivers have tributaries. Glaciers also have tributaries. If I've got a smaller tributary glacier meeting onto a larger main glacier, when they've all vanished and they've all melted away, the U-shaped valley that the smaller glacier made is going to be smaller than the one the larger glacier could make. So it will look like it's hanging in midair, and you can see that here. And you very commonly will have this little U-shaped valley here meeting onto a larger one, and you'll commonly see you'll have waterfalls, etc. on the side as well. Now, those are our two kind of main core erosional features. We've got a number of other ones that we can discuss as well. First, we've got roches moutonnées. Now, these are formed when you've got more resistant material in a glacial valley. So I've got a glacier moving down through a valley, and it's eroding all the stuff in front of it, but then through some quirk of geology, there's a lump of rock that's much harder to erode. So that's going to mean that it's not going to get eroded. The glacier is going to go up and over it, and it's going to leave it there. What will happen is we're going to see, yes, we'll get some erosion, so we'll be able to tell, one, which direction the glacier was moving, because the glacier, if you look at the diagram here, is moving in this direction. So this gentler slope indicates the kind of upstream side. of the glacier, and then this steeper slope here indicates the downstream side. You will also find something called striations running all the way up and down the backs, particularly on this side of the glacier. All a striation is a flashy name for a really deep scratch, and that's where some of that plucked material we mentioned earlier has been dug into the rock and it's dragged its way up. Next, crag and tail. It's very, very similar to roches moutonnées, but a lot larger, and they work in the kind of the opposite direction, in that the upstream side of a crag and tail is the steep side, and then we've got the much more gentler side and is the kind of downstream side. Now this is much bigger, and it forms where if we've got a glacier that's moving down a valley and it hits a really big block of hard rock, it hits it and it has to go around it. It can't go through. Because it has to go around it, we've then got kind of like a shadow where we've got softer rock that normally would get eroded away, but because the glaciers had to accommodate this big chunk of really hard rock, it gets preserved. Now, the example we've got here, you can see it on screen, is the Royal Mile in Edinburgh, which is a really good example of this. If we move on, we've got Knock and Lochen landscapes, which, in addition to being really fun to say, are areas where you've got intermittent amounts of hard and soft rock, and particularly up in the Northwest Highlands. You've got lots of areas where you're going to intersperse with Lovisian gneiss, which is very, very hard. Now that remains as like little roches moutonnées, and then all of the rock around them gets eroded down, and then they fill with water, creating very small lochens. And if you look this, this image, it's not brilliant at demonstrating it, but it does not a bad job. All of these raised areas of rock, these are our knocks, and these kind of the more depressed areas where we can see little pools of water, those are our lochens. Now, our last one, and it's not strictly speaking an erosional feature, but it can create some stuff that looks very much like erosional features, are meltwater channels. When we've got periods of times when we've got glaciers retreating, we are creating vast volumes of meltwater. Now that meltwater is going to flow away from the glacier, and it's got a huge amount of pressure behind it, so it can do a huge amount of erosive work. Now we're going to talk more about that in our video that looks at glacial depositional features, and that really comes under some of our fluvial glacial features, so water as in fluvial as in river, and ice as in glacial features there. Now I'm going to wrap things up here, guys. Now I've went through a huge amount of information in this video in coming on 13 minutes. So it's a huge amount of information in a very small period of time. So please remember, go back over the video, take things at your own pace. We'll discuss this stuff in class. And until next time, I'll see you guys later.